the structural characteristic of a polycrystalline is the distribution of the orientation of its crystalline that compose it. Bismuth manganese oxide can be fully described when the texture concept is incorporated. Good day everyone, my name is Glory Valentine from the Center for Research in Advanced Material Science in Math. I thank the organizers of this conference for making me share part of my doctoral research. The subject of my presentation is texture and non-texture bismuth manganese oxide on silicon films. These are the contents that will be covered in the course of this presentation. We have the introduction, the objective, the experimental details, computational method, results, and discussion. Finally, conclusion. Introduction. What really makes bismuth manganese oxide very unique is its properties of ferroelectric and ferromagnetic at room temperature. Bismuth manganese oxide is a magneto-multiferroid, and it has turned out to be an object of interest due to its freedom, that is, ability to control electric and magnetic order parameter and vice versa. Here illustrate the different cross-coupling that can exist within this material. We have a niche hysteresis loop. These are the coupling that can exist. We have the magnetic, the multiferroid, and the ferroelectric. This coupling between parameters of this corresponding order open interested perspective for the design and application in the field of microelectronics and spintronics. Bismuth manganese oxide crystallizes in monoclinic space group of C2 at room temperature with the lattice parameters as mentioned here. The objectives are to synthesize and grow characterization of radio frequency magnetron sputtering bismuth manganese oxide on silicon substrate. Then characterization of the crystalline structure of the films by X-ray diffraction in grazing incidence and Bragg-Brentano geometry. We also propose a Gaussian-shaped inverse pole figure with two modulating factors, namely inverse pole figure and direct pole figure, to analyze in details the orientation of bismuth manganese oxide thin film. Here is the experimental details, but before having the parameter, a section of 1 by 1 centimeter square of the substrate was suffocated in acetone for 10 minutes, then cleaned by successful rinse in ultrasonic bath of distilled water for 10 minutes, then with alcohol for 10 minutes and the ionized water after each solvent. The purpose of this cleaning was to remove the organic residue from the silicon, and it was blown with a dry air before loading into the chamber. And inside the chamber, these were the parameters with the corresponding observed values. Computational method. The integrated intensities of the X-ray diffraction peak are affected by the crystallographic texture, and these depend on the measurement geometry. Here we have that the incident beam intensity and decay used here was the instrumental constant. Our F is the structure factor, P multiplicity factor, and here is the Lorentz polarization factor, A assumption, and D the Davis-Weyl factor. Our V is the cell volume and the T is the texture factor. So we have the different configuration here, in Bragg-Brentano and also in grazing incidence. In grazing incidence, the modulating factor are the corresponding direct fold figure evaluated by the Bragg angle. This model applied to this work consists of a Gaussian-shaped infield figure, and proceeding with further calculation on dependence are being considered. So we have this model here where the phi denote the polar angle measured from the location of the IPF, and the sigma is the standard derivation of the orientation distribution, where the R0 is the normalization constant such that the integral here over the whole unitary phase has a value of 4 pi. Here is the calculation of the pole figure from symmetry axis. The inverse pole figure proceeds by the application of the fundamental equation of the fiber texture. Results and discussion. Here we have the different geometry of our experimental results. The A is the grazing incidence, which is denoted here, the 2D XRD pattern, and C here is the Bragg-Brentano and is also represented with it corresponding to the XRD pattern. The intensity here are not intense as the Bragg-Brentano results, and here we could see that the peak that is more intense in the Bragg-Brentano is practically invisible here. Also, from the crystal plane, the 0, 1, 2, from the angle of approximation 26 degrees with the sample is not visible in grazing incidence geometry. We have the inverse pole figure for the model axis texture bismuth manganese oxide. We can conclude that bismuth manganese oxide thin film will successfully deposit on silicon substrate by radio frequency magnetron sputtering method, and a Gaussian-shaped inverse pole figure was proposed with two modulating factors, namely inverse pole figure and direct pole figure, to analyze in detail the texture orientation of bismuth manganese oxide thin film. The Bragg-Brentano resulted in a textured and intense peak of -112 crystal plane parallel to the substrate surface. In grazing geometry, without texture. So Bragg proved to satisfy this condition. Thank you very much for listening. Support from CONACYT and the members of staff at the Center for Research in Advanced Material Science, CIMA, is greatly acknowledged. I will be glad to answer all your questions.